Dear students, hope you are great. Today we're going to take chapter 5, the periodic law, section 1. By 1860, more than 60 elements has been discovered. There was no method of organization these elements or linking them together, and to make things worse, there was no commonly agreed upon method to determine an element atomic mass or the chemical composition for a compound. Different chemists use different atomic mass for the same element. That made it nearly impossible for one chemist to understand the result of another. In September 1860, a group of chemists assembled at the First International Congress of Chemists to put an end to the confusion. A chemist named Canezro presented methods for accurately measuring the atomic mass. So the chemist Canezro make a method for accuracy measuring the atomic mass. Second scientist who come after Canezro, which is called Mendeleev periodic table grouped elements by their properties. When the Russian chemist Dmitry Mendeleev heard about the new atomic mass discussed he decided to include the new value of agreed upon atomic mass in the chemistry textbook he was writing. He placed the name of each known element or each element on a card together with its atomic mass and some chemical and physical properties. So Mendeleev got names of elements and put it like this in a card. According to what? According to atomic mass and its chemical and physical properties. He arranged this card by increasing atomic mass. So I arranged this card according to increased atomic mass. He noted that certain similarity in certain properties appeared at irregular or periodic interval. He see that there is a similarity in properties according or at regular or periodic interval. He left place for soon to be discovered element and predicated their properties with a very high precision. His first periodic table was published in 1869. Note that Mendeleev placed iodine atomic mass 100, iodine atomic mass 127 after tellurium atomic mass 128. Also, this contradicted the pattern of listing the element in order of increasing atomic mass. It allowed Mendeleev to place deuterium in a group of elements with which it shared similar properties. Moistly arranged elements by their atomic number. In 1911, an English chemist called Henry Moseley, who was working with Rutherford, discovered that elements in the periodic table fit into patterns better when they were arranged in increase according to number or according to atomic number rather than atomic mass. So Moseley, who got after Mendeleev, he noted that when arranged elements according to atomic number is better or fit the pattern of the periodic table more than according to atomic number more than atomic mass. The periodic law. What's meant by periodic law? The physical and chemical properties of the element are periodic function of their atomic number. In other words, when elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. So what's meant by atomic law? Periodic law. Periodic law. The physical and chemical properties of elements are periodic function. The physical and chemical properties of each element are periodic function. Periodic function, which is mean physical and chemical properties repeat interval or repeat periodically like this. In other words, when elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. According to Moseley, tellurium with atomic number 52 belongs before iodine, which has an atomic number 53. Modern periodic table arrange the element by both atomic number and properties. Periodic table arrangement of elements in order of their atomic number so that elements with similar properties fall in the same column or group. What about modern periodic table? Modern periodic table arrange the elements in order of increased atomic number, and elements with the same properties fill in the same group. For example, group 1 have a same chemical and physical properties. Noble gas, which is group 18, last group in the periodic table. Noble gas were discovered later after the periodic table was made due to their total non-reactive. As a noble gas, total non-reactive. Then follow them the lanthanide, the top line of the elements in the bottom of the periodic table. Lanthanide are 14 elements with atomic number 58. Cerium 271. Lutetium. Then follow them actinide, the bottom line of element in the bottom of the periodic table are 14 elements with atomic number 90 to 103. Look. So first discovered noble gas, which is total. This is noble gas, which is total non-reactive, and then lanthanide, which is 14 element, and also actinide here. So discover first after periodic table noble gas, then lanthanide and actinide. Lanthanide and actinide belong in period 6 and 7 of the periodic table between elements of group 3 and 4. So lanthanide and actinide here between period 6 and 7 here, and group 3 and 4 here. But lanthanide and actinide put under below the periodic table to make periodic table too wide. Now, so again, first the periodic table or elements arranged according to atomic mass, which is done by Mendeleev. Then come Moseley and Rutherford arrange elements according to nuclear charge or the number of proton or atomic number, not atomic mass. What's meant by atomic law? Atomic law state that physical and chemical properties of each element repeated periodically, like this, repeat periodically. In other words, so when elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. What's meant by a periodic table? An arrangement of elements in order of increased atomic number so that elements with similar properties fall in the same group. Look at this periodic table. Group 1 has similar has a similar physical and chemical properties. Group 2 has similar physical and chemical properties, and so on. So each group has similar and physical chemical properties. That's it. Thanks for watching.